Every year, billions of dollars are invested in mangrove restoration, yet in wave-exposed areas, up to 50% of newly planted mangroves fail within the first year. The issue is not biology, it is early-stage mechanical instability. I'm Pumipitak.
And I'm Narith Markawat from Ruamrudee International School, Thailand. Mudlock is a biodegradable subsurface anchoring system designed for early-stage mangrove survival by redistributing hydrodynamic force. Instead of competing on permanent strength, we redefine stabilization around early-stage reliability. The problem lies where young mangroves do not yet have strong root systems. In exposed coastlines, waves hit where roots are weakest. Most stabilization methods use vertical stakes that hold at one single point. This concentrates force in one area and causes sediment to wash away. As a result, projects repeatedly replant in exposed zones, increasing cost and delaying protection. No existing system optimizes stabilization for the early stage vulnerability window. Because of this, we engineered and fabricated a functional prototype to test variations in weaving, density, dimensions, and strength to ensure our structure could provide temporary mechanical protection.
Today's stabilization systems compete on structural strength, durability, lifespan, and rigidity. They oversupply durability and permanence while underserving early-stage survival and environmental compatibility. Mudlock creates a new category, biodegradable subsurface anchoring engineered specifically for early growth. We eliminate permanent hard materials, we reduce lifespan beyond root maturation, we raise early-stage survival performance, and we create a force redistributing biodegradable anchoring. The to-be canvas shifts values from permanence to hydrodynamic alignment and biodegradable exit strategy. Low cost comes from eliminating permanence and reducing replanting cycles. We redefine stabilization standards. Mudlock is placed subsurface at the sediment interface, where its woven geometry redistributes wave force laterally instead of concentrating it vertically. We modeled this inside a controlled current flow domain at sediment level. The simulation shows clear downstream velocity attenuation compared to a vertical reference structure with peak force concentration reduced by approximately 60%. The innovation is engineered force redistribution, not added strength. No new materials, no new technology.
Mudlock improves productivity, meaning fewer replanting cycles, cost, lowering life cycle expenditure, and environmental impact, leaving no permanent debris. This reduces project risk without increasing budgets. Mudlock expands demand across three tiers of non-customers. First tier, including high-failure mangrove projects that continue replanting but are close to abandoning restoration in exposed zones. Second tier, coastal engineers and hard infrastructure developers who reject biological restoration due to reliability concerns. And the third tier, climate-focused corporations and ESG investors who have not considered civilization investable. By increasing reliability without raising cost, Mudlock converts hesitant buyers. Mangroves protect over 150 million residents and prevent approximately $850 billion in annual flood damage. If 5 million hectares are restored and 40% require stabilization, that equals 2 million hectares. At $8,000 per hectare, this represents a $16 billion restoration opportunity. Southeast Asia represents up to $1 billion of serviceable available market, where coastal exposure and restoration activities are very high.
Mudlock operates within existing restoration budgets. Production cost is $1 to $2 per unit. Selling price is $5 to $7, generating a 65 to 75% gross margin. At 900 units per hectare and being $6 per unit, revenue equals $5,400 per hectare, being within the median $8,000 restoration benchmark. Preventing just one failed replanting cycle offsets full deployment costs. At 1,000 hectares annually, our serviceable obtainable market is approximately $5.4 million. We have already contacted coastal restoration operators for a pilot deployment by March and secured engineering advisors. Our product launch plan consists of three phases. Phase 1, field pilot and survival data collection. Phase 2, integration into provincial contracts and procurement standards. Phase 3, decentralized biodegradable production hubs across Southeast Asia. Mudlock integrates into existing workflows, requiring no new infrastructure. Mangrove restoration succeeds when early growth is structurally protected. Mudlock addresses that vulnerability. With the completed prototype, validated force reduction, and pilot deployment underway, Mudlock establishes a new category in coastal resilience, stabilizing nature from the ground up.